um you have a function, limit of fx is equal to L as x goes to a. So if you take, for instance, you plot fx, you get this curve. So on the x-axis, let's take for this limit to exist, we must have a distance delta from a, such a way that when you pick an x from this value, from this area, that is x not an x, when you take x from this area, you're going to get the value of the function that is within the epsilon interval. So here is the definition. Precision definition of limit implies that picking a value of x inside the delta interval will return a resulting value in the epsilon interval. So the summary of this part actually is very simple. So summary, here you have a function whose limit is given here. This function is true, this expression is true, given that these two inequalities are true, whereby f of x minus the answer which you get here is less than epsilon, and the epsilon we know it's on the y-axis, and x minus a is less than delta. This 0 just shows that delta is a positive value. So let's do an example. So prove that limit of 2x minus 3 is equals to 5 as x goes to 4, that is as x approaches 4. So first of all, we do the substitution part, and when we do that part, we get this value here. We get that is very true, 5 is equals to 5, and then from there we just comment. So for these two inequalities, so here we have this one over here, and then we have the other one over here. So both of these have to be true for this one to be true too. So this of this, and you get that x minus 4 absolute is less than epsilon over 2, and then you get this one is equal to this. So you express this one in terms of epsilon, and you see this one is the relationship. So as far as this relationship here exists, so therefore as far as the relationship epsilon over 2 is equal to delta holds, we know that 2x minus 3, that is the function, will fall inside the epsilon interval whenever we pick a value of x that is inside the delta interval. That's all to it. Thank you.